Picture this, an AI that can comb through thousands of chaotic news reports and social media posts during a crisis and acts like a detective, pinpointing the exact information needed to save lives. Well, that's not science fiction anymore. It's a real technique, and we're going to break it down today.
So think about a really complex situation, like the ongoing conflict in Sudan. You've got humanitarian groups on the ground who desperately need to know precisely where and when things are happening so they can deliver aid safely. But in this absolute flood of information, where do you even start looking?
And the crazy part is, it's all hidden in plain sight. It's buried in the sentences of news articles and random social media updates. All the specifics, locations, dates, times, it's all there, but it's locked away in unstructured text. That makes it incredibly difficult for a computer to just pull it out quickly and accurately.
All right, so here's our game plan. We're going to start with the data challenge itself, then look at why the first tools they tried had some big problems. We'll explore why even powerful AI can have a context crisis, and then reveal the open book solution that changes everything. And of course, we'll see how it all performed and why this really matters for building a safer world. So, a team of researchers decided to tackle this exact problem using hundreds of news articles from the Sudan conflict. The mission? Process all of them and pull out perfectly structured data for every single incident. We're talking the neighborhood, the state, the country, and the date.
But this is way harder than it sounds. You're dealing with really complex descriptions, like near the main market or in the eastern part of the city. Sometimes a single article mentions 3 different incidents in 3 different places, and the output format has to be perfect. If there's a single error, the whole automated system breaks, and a person has to spend hours cleaning it up by hand.
So, what was the first stab at solving this? Well, the researchers went for the traditional tools, the stuff that's been the go-to in natural language processing for a while.
The main one is called Named Entity Recognition, or NER. The easiest way to think about it is like an automated highlighter. It's built to scan text and tag any words it thinks are locations or dates. It's a decent first step, sure, but it's just too simple for this kind of messy, context-heavy work.
And the results? Yikes, they speak for themselves. The NER tool scored an F1 accuracy of just 40.8%. Let's be clear, that means it was wrong more often than it was right. In a life-or-death situation, that's an absolute non-starter. Okay, so the simple tools failed. What about the big guns? Let's bring in the large language models, the LLMs. You know, the super smart AI behind things like ChatGPT. You'd think they'd nail this, right? Well, it turns out they have their own problem, a context crisis. Now, check this out, because this is fascinating. The source text clearly said an incident happened on May 2nd. But look at what a standard LLM did. It got the location right, Liba, South Darfur, Sudan, perfect. But then for the date, it just put a generic placeholder. It knew a date was supposed to go there, but it just couldn't reliably pull it from the text. The other big problem is that LLMs, well, they like to talk. They'll often add little explanations or use conversational formatting. And while that might be nice for a human, it completely breaks an automated data pipeline that needs just the data, perfectly structured, no fluff. And this is where the hero of our story comes in. The breakthrough that solves these problems is a technique called Retrieval Augmented Generation, or RAG, and it completely changes how the AI approaches the entire task. The absolute best way to understand RAG is to think of it as an open book exam for the AI. A normal LLM is like a student taking a test from memory. It knows a lot, for sure, but it can forget or mix up the details. But with RAG, the AI gets to have the textbook, the original news article, open right in front of it while it's answering your questions. So how does this actually work? It's a pretty slick 5-step process. First, all the news articles get indexed into a searchable database. Then, when you ask a question like, find the location and date, the system instantly retrieves the most relevant snippets from those articles. Step 4 is the magic part. It augments your original question by tacking on those snippets. And finally, the LLM generates an answer, but now it's using that perfectly relevant open book information. Okay, so the theory sounds amazing, but how did RAG actually do when they put it head-to-head against all the other methods? Let's get to the results. The study lined up a whole bunch of techniques. You had our old friend NR, a standard out-of-the-box LLM, a few other fancy prompting strategies, and, of course, the RAG-tuned model.
Each one had its own issues, but one was about to blow the others out of the water.
And wow, this chart says it all. Look at NER, way down there at 40.8%. The standard LLM makes a huge jump to over 88%, which is impressive, but still not perfect. But then you see the RAG-tuned model, and it pushes even higher to a stunning 91.8%. That's not just a small bump. It's a leap into a whole new class of reliability.
And that right there is the key takeaway. Over 90% accuracy. That's the number that transforms this from a cool experiment into a tool you can actually trust to provide life-saving intelligence when every second counts. So this all leads to the most important question of all. Why does this really matter? What does a breakthrough like this actually mean for the real world? Well, this tech goes so far beyond this one conflict. Imagine using it to track the spread of wildfires or the impact of an earthquake in real time just by reading local news and social media. You could monitor pollution, help cities plan better. You could even create maps automatically just from written descriptions. It's all about getting smarter data to make faster, better decisions when it matters most.
And that leaves us with a pretty incredible thought. For really the first time, we have a reliable way for AI to read and actually understand the world as it's being reported, pulling that critical signal from all the noise. So if it's reading the news for life-saving data today, the real question is, what will it be reading for tomorrow?